Welcome, everyone. Good evening. Thanks for joining us for Artemis, Returning to the Moon. So before I introduce our presenter this evening, I just want to say hello and introduce myself. I'm Christina. I run the adult programs here at the Bloomingdale Library. And if you enjoy tonight's program, we're going to have this presenter back with us on September 30th for Comets and Asteroids. That's going to be another Zoom presentation. It's already up on the calendar, so you can sign up for that tonight. Comets and Asteroids on September 30th. All right, and then for some upcoming virtual programs at the Bloomingdale Library on Monday, June 10, we're going to have a travel program. We're going to virtually travel with our travel enthusiast, Jean Flynn, to Normandy, the D-Day beaches, and Brittany. So we're going to take a little trip abroad for that on Monday, June 10, Normandy, D-Day beaches, and Brittany. And then in July, we're going to have on Monday, the 22nd, Life on the California Trail. And this is our outdoor enthusiast, John Lynn, who is going to talk about his 1,000-mile path from the Oregon Trail at Fort Bridger, Wyoming, to the Alder Creek and Donner Lake camps, where the Donner Reed Party were stranded for the winter in the Sierra Nevada mountains. So Life on the California Trail, July 22nd, Normandy, D-Day beaches, and Brittany, June 10. We have a lot more in-person events happening at the library as well. So if you feel like coming into the library, there's lots going on. And we're also going to have a bunch of summer concerts, June, July, August. We have a concert on a Friday afternoon at 12 o'clock, so you can join us for a free concert then too. All right, so our program again tonight is Artemis, Returning to the Moon, and we have Astroeducator Michelle Nichols with us. Hi, Michelle. Thanks for coming back.
Thank you so much. And I am so excited to talk about something not the eclipse.
Yeah.
Although don't get me wrong, I love talking about the eclipse. It's nice to talk about something else besides the eclipse. So anyway, would you like me to take it away?
Yes.
All good on your end?
Please go ahead. Thanks.
All right. Well, thanks everyone. I know you're out there. I know there's quite a few of you out there. My goodness. Thank you for joining us on a nice, a little bit muggy Monday evening in May. So yeah, we're going to talk about the Artemis missions. If you haven't yet heard of the Artemis program, this is NASA's program to return astronauts to the surface of the moon. Now, I'm going to be a little cagey as to the dates because as with anything involving people and space and technology and doing something either new or something that hasn't been done in a long time, these things take time. Usually they end up taking a lot longer than people originally planned for. So I will give you some dates as I know them, but please keep in mind that everything that I'm going to tell you that might have a date attached to it is probably going to change in the future, just because timelines are just going to get stretched out. But I'm going to describe what the Artemis program is. And the best way to do that is to talk about some of the initial missions and what each one is going to accomplish. One of the criticisms of the Artemis program is it's complicated. And so there will be points during this program where you will probably look at what I've got on the screen and go, what in the world is she showing me? Don't get flustered. Don't worry about that. I'll do my best to describe what is an incredibly complicated program. This is not as simple as put astronauts on top of a rocket, send them to the moon and bring them back. There's a lot more to this. So if you get lost in the details, it's okay. As the program lives on over the next few years, more and more of it will make sense. Just let some of those details wash over you. It's okay. It's okay to be confused at this point because there's only been one Artemis mission so far. So it's all right to be confused. But I'll do my best to try to keep you from being confused. All right. So let's get started. Okay. So our closest neighbor in space. You got to see it during the eclipse, and now we get to see it in the daytime or nighttime sky. The Earth's closest neighbor is our moon. And it is easy to see in the sky when it is out there. And for a very long time, we wondered what the moon was like. And in the 20th century, we finally got a chance to first send spacecraft there, and then we sent people. But we're going to start with the quick overview of the spacecraft, some of the spacecraft missions that came before. Um, First off, there were the Lunar Ranger missions, and these were from 1961 to 1965. And basically, what they consisted of were cameras that were attached to a spacecraft. And think of this as just lobbing a spacecraft at the moon. These spacecraft were not supposed to land on the moon. They were going to crash into the moon. So they'd be taking pictures, several hundred pictures, all the way down to the surface of the moon. So every few seconds or so, they would be taking a picture. And then as you got closer and closer and closer, you could see the surface of the moon with more detail than we could using telescopes from the surface of the Earth. We couldn't yet send spacecraft into orbit around the moon, not yet. And so what you're seeing here are 4 of the images, and there were hundreds and hundreds more for the Lunar Ranger 8 mission in 1965. So on the upper left of these 4, that's one of the pictures. And then a little while later is the next picture down in the lower left. Lower right is another picture, and you can start to see that these images were made with the camera scanning over the surface of the moon and then taking these in strips essentially. And then that final picture, the spacecraft was in the process of sending that picture back to the Earth when it crashed. And so the rest of the picture was not able to be sent back. But what did we learn from these pictures? Wow, there's a lot of craters on the moon. But it at least showed us that we had the ability to get a spacecraft there. Then later, we were able to send spacecraft into orbit around the moon, and these were the aptly named lunar orbiter missions, 1966 and 1967. And this particular picture, I love this one. This is from Lunar Orbiter 3, and this is Kepler crater. And there's 2 reasons why I like this picture. First off, it's taken at kind of a low angle. And so with the sunlight on the surface of the moon, you can see all the stuff that when the object from space slammed into the moon and made the crater, the stuff that splashed out is all that rough looking stuff around the crater. And so you can see the stuff that was inside the hole of the crater originally. I like it for that reason. And the other reason I like it is you can pretty much fit the city of Chicago inside that crater. It is 20 miles wide. So that's a pretty large crater as craters go on the surface of the moon. Then we were able to land spacecraft softly, not crash them, but land them safely on the surface of the moon. These were the lunar surveyor missions. And what the lunar surveyor missions were able to do is solve a bit of a mystery about the surface of the moon. There were essentially a couple different camps of scientists. One camp said, sure, you can land stuff on the moon. The other camp said, no, 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 the moon has been pulverized by stuff for billions of years. Well, actually, we didn't know for how long. For a long time, the moon had been pulverized by things from space. And what if the dust on the surface of the moon was way too thick? And if you tried to land something like a big spacecraft carrying people on the surface, what if it sank into the dust and you couldn't get that spacecraft back off the surface? Was it safe to do this? So the only way to find out is to send a robot, have it land on the moon, have it take a picture of its own feet. And so that's what you can see in this picture here. You can see one of the spacecraft feet of Surveyor 5, and then you can see the foot is sitting nicely on top of the surface of the dust. Turns out, on average, the dust on the surface of the moon is only a couple inches thick. So underneath that is some solid rock. And actually, that played a part in Buzz Aldrin planting the flag of Apollo 11 on the surface of the moon when he stuck the flag into the dust. Only a couple inches of it to hold on to the flag, and so he was actually afraid for a little while that if he let go of the flag, it was going to fall over. Not a good thing to do on live camera. So eventually, kind of got it wedged in there so that it did not fall over, at least not while people were standing there on the surface of the moon. This is the picture of Surveyor 1. And you can see the shadow of Surveyor 1. It took its own picture here. We've got it taken from the surface of the moon. Over here, the lower right, this is Surveyor 3, which is upper right. And what you can see in the back is one of the lunar landers. So the Apollo 12 mission landed near Surveyor 3, and the astronauts trundled over and they grabbed a few pieces off of this spacecraft and brought them back to Earth. It was a great way to do a little experiment, not only for seeing what happens when you leave spacecraft parts out on the surface of the moon for a couple of years, but also could we pinpoint a moon landing close enough to another location to be able to do something like this? So turns out the answer was yes, we could. All right. The Apollo program. I mentioned Buzz Aldrin. He was one of the astronauts on the Apollo 11 mission, which was the first mission to safely land humans on the surface of the moon. He and Neil Armstrong landed, and there were 6 successful moon landings with people. There should have been 7. Apollo 13 was supposed to have landed safely. It did many other spectacular things. It just didn't land on the surface of the moon. But people often ask me, why should we go back? Haven't we been there, done that? What could we gain by going back? Well, let's figure out a little bit of what we got out of the moon landing missions. First off, we got a lot of technology advances. So that kind of goes without saying. With every space program, there are going to be technological achievements and things that you don't even think about originally when you're designing the mission that you then get as spin-off technology that then goes out into the wider world. But there was a lot of scientific advancement as well. A prime focus of all of the lunar missions was to learn about the lunar environment and the geology. This is astronaut John Young in this picture here. By the way, if you notice the red stripes, it was apparent pretty quickly during Apollo 11 that we had no easy way of distinguishing the 2 white suited astronauts. And so later missions had stripes on the spacesuits so they could tell them apart, because it was kind of impossible to tell Buzz Aldrin and Neil Armstrong apart. Anyway, so if you're seeing those red stripes and you go, wait, that looks a little weird, that's because those were later, later additions to the missions. But this is John Young, and this is during Apollo 16. And surrounding him were a number of the lunar science experiments that were left on the surface of the moon. And the various experiments, we had the lunar surface drill. So in this picture, it's in 2 pieces, but you would use the drill to drill down into the rock and get samples down below the surface. What's really interesting for all of you who own a dust buster at home, your dust buster battery operated portable motor is a direct descendant of the lunar surface drill. Basically, long story short, Black & Decker looked at the lunar surface drill and went, huh, you're able to get a small motor that can operate and not have to be tethered to something else to be able to supply power. Interesting. We can do something with that. So they did. So if you have a dustbuster, it's because of the Apollo missions. Anyway, so the lunar surface drill is there. We could detect magnetic fields in the area right around the lunar landing locations. The moon does not have a moon-wide magnetic field, but you can get local magnetic fields and detect them using that gizmo right there. We've got the power source that's powering all this stuff, and so that is the surface power source for the instruments that you're seeing on the surface. Heat flow detector. Basically, you can learn about the different layers below the surface by detecting how much heat is coming out of the surface. How heat escapes from the ground tells you about the interior of a world. So we can do it on Earth, we can do it on the moon. We've got the passive seismic experiment. You probably know what a seismic experiment is. It detects ground rumbles and shakes and moonquakes in this case. So when if something were to hit the surface of the moon, it would send rumbles through the ground, and those could be detected by this instrument right here. But if you think there's a passive seismic experiment, is there an active seismic experiment? The answer is yes. I'll get to that in just a second. This is the center station right here. It gathers and transmits data to and from Earth with the passive seismic experiment and the active seismic experiment. Basically, you got to love, I would love to know who the person was who came up with this idea, or people, the team probably, who came up with this idea. It's not just enough to wait for stuff to hit the moon. Let's actually hit the moon with stuff. And so this instrument here would lob mortars at the moon, and they would explode, and the rumbles would send waves through the rock. So again, you can learn about the area underneath these landing sites by detecting the waves through the rock and through the ground. It allows you to be able to learn about the interior of a world without having to dig down into it. So, all right. One of the main things we learned from all this information was some constraints on the origin of the moon itself. And we learned this from the rocks that the astronauts brought back. Basically, there was a lot of question, where did the moon come from? Probably thought about it before, right? We actually pretty much have an answer to that question thanks to the Apollo program. The moon very likely came from a Mars-sized object hitting the early Earth and kind of doing a glancing blow, and the material that splashed out essentially coalesced and formed the moon. And there was a question, could the moon have been captured by the Earth? But the rocks of the moon and the rocks of the Earth are quite similar to each other, too similar to each other to have come from two completely separately derived worlds. So, putting some constraints on all that, we were able to basically say, okay, the moon wasn't from this or wasn't from that. It was likely from something hitting the early Earth. We learned about the conditions at the surface of the moon. We learned about the surface of the moon itself. We learned about the subsurface areas. There's a lot that we learned. The Apollo missions landed near the moon's equator, however. If you take a look at all the landing sites, they're not that far apart from each other. This is all on the near side, the side that faces the Earth. There are giant parts, basically the entire rest of the moon was not explored directly, especially the poles. We've had spacecraft missions since that time that have surveyed the lunar surface, but getting actual samples from other parts of the moon would go a long way to help us learn more about Earth's closest neighbor. And if you're thinking, okay, well, you've got 6 sites, 800 pounds of rocks, how much more do you need? Imagine doing the same thing on the Earth. Land in 6 different locations on the Earth and tell me everything about the Earth by landing in 6 spots. And maybe only have the people who land there only go a few hundred feet or so away from those 6 spots. Could you do it? Probably couldn't even land in Illinois in 6 spots and learn everything you wanted to learn about Illinois, let alone the entire surface of the moon. So, since Apollo, we have learned even more thanks to spacecraft that have surveyed the moon, meaning they orbited the moon and took lots and lots of pictures and data. One of the most surprising things is the ice, the actual water ice, as in the stuff that's in your freezer right now, is currently sitting in darkened, shadowed, cold craters at the North Pole and the South Pole of the moon. These 2 pictures here are pictures of the 2 poles, and the blue dots are indicating all the places where we have found direct evidence that there is water ice in these shadowed craters. So, and if I'm not mistaken, I think the North Pole is on the left and the South Pole is on the right. I hope I got that right. But anyway, um, so you've got lots of water ice. Interesting. We'd love to learn more about that. Is it from comets that impacted the moon and the ice may have collected in the craters? Don't know for certain. Is there another process by which the ice collects? Probably. So we'd love to learn more about all of that. But this water ice could also be a resource. One of the pesky things about sending people to the moon is you have to keep them alive. And so you have to feed them and they need water and those sorts of things. But all that stuff is really expensive and difficult to lift off the surface of the moon. And the longer your missions are, the more you have to take with you. Wouldn't it be great to have some of those resources there already waiting for us and already something we could use on the surface of the moon? And you don't have to take quite everything with you. That could be really useful in the future. Well, learning more about this ice, learning more about how it got there, learning about how it interacts with the rocks and with this larger lunar environment will be a key mission focus. Learning about the moon in general, especially areas where we have not sent people before, will be a key mission objective. Well, we're still sending spacecraft to the moon that don't have people, and the United States is not the only country to have done that. There have actually been some recent missions that have done it. India last year sent Chandrayaan-3, which is the spacecraft you're seeing here. And the reason we have a picture of this spacecraft is it also sent a little rover. And if I'm not mistaken, the ramp for the rover is over that angle that's on the right-hand side of this picture right here. So it's called Vikram, and Vikram took this picture. So the rover took the picture of the spacecraft, and it was designed to last for a couple weeks. That's how long it lasted until lunar night happened at this particular location. And it was searching for frozen water in the lunar surface and learning about the rocks. And so we're still waiting for the results of all that to be published. But it was really exciting that India became the fourth country to successfully soft land a spacecraft on the moon. The United States, Soviet Union, and China being the others. So India, we can add to that list as well. Well, Japan can be added to that list. This is the Japanese SLIM spacecraft. This is what SLIM should have looked like when it landed. Again, no people on this one, but Slim was going to tell us about this lunar environment here. This is an artist's representation, a very good one, about what Slim should have looked like when it landed. Well, this is what Slim looked like when it landed. This picture was taken from a small craft that was ejected from the main one right before it all landed. One of the two main thruster rockets on the spacecraft, and SLIM stands for Smart Lander for Investigating Moon, SLIM, one of the main thrusters stopped working. And so essentially SLIM bounced and tipped over. So SLIM was on its head. So SLIM should have been SLIM was all the way over and tipped itself over. So yeah, it kind of a success, sort of. It definitely soft landed. It did operate for a short while. So you could say it was at least a partial success. So Japan can be added to that list. And then there was earlier this year a private spacecraft that successfully landed, and Intuitive Machines, their Odysseus lander. So you can see what the lander should have looked like there on the lower left. Do you notice something odd with the legs of this lander in this picture right here, the center part? I think you can see my arrow. Do you see that at least one of these legs is not looking like the others? Well, unfortunately, one of the legs broke on landing. So when it landed, this next slide is going to show you approximately what it looked like. And it was tipped over. So not quite as severe as this model is here. The lander came in a little too fast. It skidded and it tumbled over. It broke one of the legs in the process. But it did successfully work for a few days. So partial, at least a partial success for that one. So there are going to be more of these unmanned, uncrewed spacecraft that are going to be landing over the next several years with uh, private companies taking public and private scientific missions that are going to help us learn more about the moon before we send people again. So I wanted to highlight those to show you that lunar exploration does not stop just because we don't have people on the surface. We've got exploration from people, from spacecraft that land, and from spacecraft that orbit. And so all of this together helps us learn. But the way that we can find out information the quickest often is to send people. Unfortunately, that is also the most expensive and the most complicated way to send a spacecraft. So anyway, I want to talk about Artemis at this point. So Artemis is the follow-on mission to Apollo. Who was Artemis? Artemis is the twin sister of Apollo, the Greek god Apollo. But Artemis is the name of the program that will allow us to return to the moon. The goals will be land the first woman and the next man on the moon, including sending a person of color, explore more of the lunar surface than we've been able to explore before, and then use what we've learned from exploring the moon to eventually send astronauts to Mars. Now, giant caveats on that last line right there. I will not be able to tell you, oh, in X number of years, we're going to send people to Mars. There is no way that we will be able to know for certain when or if we're going to be able to send people to Mars. We need to get people back to the moon first before we can think about that. So I am not able to tell you. I know people are going, so how many years before we go back to, or before we send people to Mars? It's been for the last 40 years. It's been, oh, it'll be 30 more years before we send people to Mars. It'll be another 30 years, another 30. Well, it's been 30 years for the last 40 years. So I don't know when we're sending people to Mars. I hope it's in my lifetime, but I can't guarantee that it will be. Um, but the rocket that's going to get us to the moon is already in existence. This is called the Space Launch System, and the spacecraft is called Orion. So the rocket itself is 177 feet long. Each of these rocket boosters on the side is about as tall as the Leaning Tower of Pisa. Each of these boosters weighs 1.6 million pounds. And the job of these boosters is to help get this whole rocket going fast enough that it will eventually escape the Earth's gravity and send the spacecraft eventually, sending it on its way to the moon. While the Space Launch System rocket is a little bit shorter than the Saturn V rocket was, the Space Launch System is more powerful. So it is definitely packing a lot of punch. By the way, if you're looking at this picture going, wait a minute, haven't I seen some stuff in the past that has looked like this? Doesn't that look a lot like space shuttle technology? And the answer is yes, it does, because it is. So the rocket boosters themselves are a little bit longer than the rocket boosters were for the shuttle missions. But those are absolutely using shuttle technology. Basically, it works. And so why develop something brand new when you have this booster rocket system that already works? And this system in the middle, yes, it looks a lot like an external tank from a space shuttle system because that is the technology that it is based on. Updated materials, but it is based on that original shuttle technology. And so the cone-shaped top part up here is what holds the Orion spacecraft. And of all this stuff that's here, the only part that returns to Earth is the Orion spacecraft right here. All this stuff, this bottom part and the booster gets you going fast enough into space. The rest of this is then attached to another, is already attached to another rocket that gets you going even faster. this and that jettisons. This one right here gets it going even faster. And then it all goes to the moon. And this part with the people is the only part to return to the Earth. So basically, once you get going fast enough, you get rid of the heavy stuff and then you keep on going. So it sounds complicated. Trust me, it's going to get even more complicated. But let's take a look at some of this real hardware. This is the Orion spacecraft. It's the conical part there at the top. And the cylindrical part below it is the service module. The service module is produced by the European Space Agency. And basically, that is the European Space Agency's contribution to the whole Artemis mission. And so the part at the bottom provides the electricity and the water and the oxygen, as well as keeping the spacecraft at the right temperature and keep it going in the right direction. So this is an actually very important part of the whole thing. Basically, what that will allow the European Space Agency to do is to get European Space Agency access to space using the Orion spacecraft. They say, we will provide this stuff if you give us a ride and give our astronauts access and give us science access to the rest of the system as well. And so basically, because the space program is a giant barter system where you exchange goods and services, not money, that's how this whole thing works. So that is the European Space Agency addition to the Artemis mission. Now, that service module at the bottom is based on an existing spacecraft that has taken cargo to the International Space Station for a few years. So again, repurpose existing technology. We know this spacecraft worked. So change some of the systems on it, have it all help keep Orion, the Orion spacecraft going. And there you go. You have the European Space Agency contribution to Orion. Now let's take a look and see what Orion looks like on the inside. Looks like a lot of room, right? Well, what you're looking at is 4 seats, so it'll carry 4 astronauts. It could carry up to 6, but here are 4 seats right here. Here's where your feet go, your legs and your feet go for this person over here on the right-hand side, and the legs of the chair behind it are a little bit hidden. But you can see over on the left-hand side, that's where the legs and feet go for those 2 astronauts. You've got a headrest right there. They'd be wearing spacesuits, so therefore you've got the headrest for a space helmet and all that. Looks a little bit spare, but let's see what a mock-up looks like with a completely outfitted uh, spacecraft. So my next slide, a lot of this is all labeled. So let me add the labels on top because that'll help you figure out what's what. All right, so I'm not going to go over everything, but just know that these are the seat back pads, and you can see where the helmets go right there. Where their feet go, that's all stored. And so we're looking in the other direction. So for this picture here, we're looking in this direction. Now we're looking from the opposite direction. So these guys over here were over on the right-hand side for that last picture. But anyway, we've got cargo netting that's going to hold down all your excess stuff. You can see there's 2 seats right here. So here's a bottom of a seat right here, bottom of a seat there. They don't need those seats while they're up in space. And so you have the cargo net holding it all down. You've got a cover that covers over all your switches and buttons and things. I'll show you what that looks like in a second. But basically, you can cover that stuff up so you're not accidentally flipping switches and things when you don't need to. The raft, well, when you come back down to Earth, you're going to land in the water, and so you might need a raft. You've got bags over here. I don't know if you can read that label. It says emesis bags. Basically, that's if you get sick in space or when you land back down in the ocean. Smoke detectors, places for your spacesuit to be connected, speakers, all sorts of stuff. Once you start adding all that stuff in, there's not a lot of room. This is about 50% larger by volume than the Apollo spacecraft. That was supposed to carry 3 people. This carries 4, up to 6. And it will be cramped still, these missions are going to last at least 3 weeks, if not longer. So there really isn't a lot of room in this spacecraft. Here's what all the buttons and switches look like. Looks a lot less complicated than maybe the Apollo spacecraft did, right? All right, here it is with people in it, not with the person on the lower right. That's an engineer. Basically, they were checking out something in particular during this. I think they were checking the placement of a few different things inside the spacecraft. So this was taken back in 2016 when they're still designing some of the interiors of the spacecraft. So really not a lot of room to be holding 4 people. Okay, so that's the spacecraft and the rocket. Powerful rocket, powerful spacecraft, a little bit bigger spacecraft, has to go pretty fast, has to get out to the moon and back safely. So, what missions have happened so far? Well, there's been one. It's called Artemis 1. And that mission, so I'm going to come back to that, what that mission was in just a second. I'm going to be showing you some diagrams. The diagrams are going to look increasingly complicated. I'm not going to go over every inch of the diagrams. They're just too complicated to do that. So bear with me. I'm going to pick out some of the important points of some of these diagrams and try to explain some of these Artemis individual missions just in general, just so they're a little easier to understand. The problem is there are no easy diagrams for these missions. So bear with me. They're going to look complicated, but I'll try to make it as painless as possible. So first one is Artemis 1. This is the least complicated of all of them. So I know you're laughing at me right now. Anyway, this was about a year and a half ago. And so they sent up an Orion spacecraft on a Space Launch System rocket, and it went out to the moon, went around a few times, came back. Simple as that. They basically sent it without people, so we could just check and make sure everything worked before we would send people on Artemis 2. This is a picture of the uh, the launch of that mission. Pretty cool. The rocket turned out to be even more powerful than we thought. It did some damage to the launch pad. There were broken panels and cabinets and destruction to some elevators, and they had to fix all that stuff. Which you never know for certain how a launch pad is going to react to an actual launch until you actually launch something. You can do some testing, but you're never really going to know for certain how it's all going to work until you actually send something off that launch pad. And so, yeah, there was some stuff they had to fix when they took a look at the launch pad afterwards. It's a pretty powerful rocket. All right. So here's a picture of the spacecraft. There's a camera on the outside of the craft, and I love this picture. You can see Orion in the foreground and the service module below it. You can see the shadow of one of the solar panels right here, and then the moon in the background. Everything worked really, really well. The service module made more power than they thought it was going to. It consumed less power than they thought it was going to. Excellent to do that, not the other way around. Everything that was supposed to come apart came apart when it was supposed to. When they landed, they had to move the landing site because of poor weather in the initial landing site, and they landed within a couple miles of the target landing location on the Earth. Also, really great. The heat shield on the spacecraft, this is the actual heat shield right here. It actually worked better than they expected, and they're not sure why, or at least they're investigating why it worked too well. And what I mean by that is less of it burned off than they thought was going to happen. So that's a little strange. Usually they're able to computer model a lot of this. And so they're able to do a lot of simulations and get a sense of how well stuff should work. So the fact that it worked even better than they thought, meaning not as much of it burned off as it was supposed to, not a problem per se, but definitely something they want to make sure they completely understand before we send up another spacecraft. Okay, that's the one that's happened. Artemis 2 is the next mission. And Artemis 2 will be the first one with all that and people. It's not going to land on the moon. All it is essentially going to recreate the Apollo 8 mission. All right, essentially. So the target launch date is no earlier than September of 2025. And what that usually means is no earlier than means it certainly won't launch sooner than that, and it may get pushed out later. So we'll see. The crew of 4 go up on a 10-day mission. They're going to launch, they're going to go into Earth orbit, and then they're going to fire the spacecraft rocket, and then it will send it into orbit around the moon. And it will go, the spacecraft itself will be about 230,000 miles from the Earth at its farthest point. So several thousand miles out from the moon. And it's going to use the combined gravity of the Earth and the moon to pull the spacecraft back to Earth. So they won't have to fire a rocket to return to the Earth. They're going to use physics and gravity in order to pull it all back. Just kind of neat. So this again is to do a checkout, make sure everything works fine, and then they will splash down in the Pacific Ocean. Sounds simple. It won't be, but we do have the crew. This is the crew. Jeremy Hansen, who is on the left-hand side. He's Canadian. He is what they call a mission specialist. So one of the, you could say one of the people doing experiments and things like that during the mission. And Victor Glover is the pilot. He's the gentleman second from the left. We've got Victor has been on one of the SpaceX missions. He's been on the International Space Station. He has spent a total of 168 days in space, so he is highly experienced in that. Reed Wiseman has been on the International Space Station. He's second from the right. He's done 6 spacewalks. Sorry, no, he's not done 6 spacewalks. Christina Koch has done 6 spacewalks. She's the lady over on the right-hand side. So Reed Wiseman has spent 165 days in space. Christina Koch has been on the International Space Station. She's done 6 spacewalks. 3 of them are all female spacewalks. She has spent a total of 328 days in space. Basically, add the amount of time that Reed Wiseman has spent in space and Victor Glover has spent in space, and they together have spent just a couple days more than Christina has spent in space in total. She is highly experienced. But this will be Jeremy Hansen's first trip into space. All right, can you imagine your first trip into space is this one? Pretty crazy. He must be a good astronaut. All right, this is the picture of the Orion spacecraft. So the crew module and the service module for Artemis 2, they've been connected together. The engines have been attached to the rocket. That's a great thing. They are working on some problems with some valves. I don't know if I think the faulty valves, I think, are in the Orion spacecraft. So they need to fix that. Hence, the mission has been delayed from this year to September of next year at the earliest. So we'll see how that goes. Okay, Artemis 3. Here's where it starts getting really complicated. So I'm just going to show this for a second. This is involving sending a couple different pieces to the moon, but it's even more complicated. My next slide, I'm going to talk you through it. Bear with me. Here we go. Artemis 3, no earlier than sometime in, I think it's September 2026. But don't be surprised if it gets pushed out farther than that. Okay, so here we go. Before Orion launches to space with the crew, SpaceX is going to launch their Starship rocket. They will essentially send an empty rocket into space. They will launch what will be an empty rocket. So a full rocket will send an empty one. So that one will be in space. Because if you launch one of these things into space, you're going to have to use up all your fuel to get it there. So you need fuel to then be able to use what you just launched into space as your landing system for the moon. So your rocket that you just launched into space is going to need some propellant. How are you going to fill it with propellant? You're going to launch somewhere between 10 and 15 more rockets that will carry fuel to this thing to be able to fill it up, to be able to have enough fuel for it to go to the moon and go into lunar orbit. Let that sink in for just a second. Then, once you've done all that successfully, assuming all of that has gone well, then you're going to launch Orion. Orion is going to meet up with this thing. The two of the crew are going to transfer over to this rocket. Two of them are going to stay behind in Orion. They will land on the surface of the moon, spend about 6.5 days there, launch back off the surface of the moon, dock up together. The crew will transfer back over to Orion and then return to Earth. Okay, so all that needs to happen. So how far are we in getting Starship ready to be able to launch all this into space and do all this propellant moving and all that? Well, there have been 3 Starship rocket tests so far. The first one launched, it cleared the tower, but about 3 minutes after launch, it had to be destroyed because it was going off target. But it did launch and get off the launch pad. The second one reached an altitude of about 100 miles, but it had to be destroyed because it experienced some problems as well. The third one, which was, I believe, in March, it launched successfully, lasted about 48 minutes. It didn't reach orbit. Suborbital is what they say. It was launched, it was lost on reentry, so it probably burned up on reentry. So they're getting a little farther with each one, but this rocket has not yet successfully reached Earth orbit. The next 2 Starship flights are scheduled for late this month and sometime in June. So I suspect the success of the next one would determine the June launch date, if that's that date or later. So I'd say no earlier than June, but possibly later. So we need to successfully get this thing into space with at least one of these missions, figure out how to do all that propellant filling of a rocket and all that, land it on the surface of the moon, go into orbit around the moon, land on the surface of the moon, take off of the surface of the moon, and do all that before we send Artemis 3. Now you start to think that that September 2026 date is looking a little shaky for Artemis 3. There is no way NASA is going to let people ride on this thing before it has successfully demonstrated all these pieces actually work. So Artemis 4 is going to involve a portion of this whole system called Gateway. Gateway, think of it as a space station in lunar orbit. Think of it as a place where astronauts can hang out in lunar orbit if they're not down on the surface of the moon. So Gateway consists of a few different parts. So we've got a depiction, not necessarily what it'll look like, but a depiction of some version of a future lunar lander here. The Orion spacecraft, which has docked. The power and propulsion element, basically the part that produces the power for this Gateway space station. We've got the Halo habitation and logistics outpost. This is where the astronauts live for several weeks at a time. And then the logistics module. This is providing water, electricity, all that kind of stuff. Basically routing all the systems through. So, and the logistics module, they will send cargo to this lunar gateway system. So this eventually will be a full-on space station that will be in lunar orbit. The habitation module and the power and propulsion element will be sent into space prior to Artemis 4. So we've got to get that built and into space and sent into orbit before they will send the Artemis 4 mission. This is Artemis 4. Essentially, send the Artemis 4 pieces, sorry, send the Gateway space station pieces into lunar orbit, send Orion to meet up with those pieces and dock, hang out there for a while, maybe land a couple astronauts on the surface of the moon, hang out there for a while, come back, dock, get back on Orion, and head back to Earth. Theoretically, September 2028 for Artemis 4. This will involve, for Artemis 5, will be a lunar lander developed by Blue Origin. So the Jeff Bezos company, Blue Origin, it's Blue Moon lander. So it will start landing astronauts for Artemis 5. Artemis 5 will take place no earlier than September of 2030. Still got a long way to go. Gateway can get bigger and more complicated. This may be what it looks like eventually, with a few more pieces added from the Canadian Space Agency, a robotic arm, the European Space Agency, Japan. A lot of the participants in the International Space Station are going to participate in the Gateway program as well. So Artemis 5, my goodness, it starts just getting more and more complicated. So again, 2030, fingers crossed for Artemis 5, but I would say farther into the 2030s. Again, I said at the very beginning, one of the criticisms of this entire Artemis program is it is extremely complicated. So a lot of stuff has to be developed and tested and flown before we can ever send people on it. So at this point, we need to get to Artemis 2 before we can even think about anything past that. What are they going to do when they get on the surface of the moon? Grab some rocks. Sounds trite, but that is actually a really, really important thing. Just like on those Apollo missions, the first thing they're going to do when they get down to the surface is grab a bunch of rocks strategically. But they are developing tools for exploring the lunar surface. Can't just reuse the stuff from the 60s and 70s. Besides, a lot of that stuff is sitting in the Smithsonian right now. But there are handles and rakes and scoops and shovels and hammers and other things that are being worked on right now and being tested. This testing was happening during the pandemic, actually. This is during 2021, if I'm not mistaken. And so a lot of this is testing, how does this stuff work? What changes need to be made? How robust do we need to make this stuff? And so this was some of the daytime testing they were doing. They were doing nighttime testing as well, because we're not going to send all the missions when it's daylight in that particular part of the moon. At times, it's going to be dark. So they need to be able to use this stuff when it is in a darkened environment as well. So here's all sorts of testing. Just how will the bags work? How will the collection sampling work? What are the procedures for keeping track of all this stuff? How will you carry all this stuff? Maybe have a little roving vehicle, all sorts of things that they need to figure out to be able to have astronauts do all this and do it while you're wearing a spacesuit. And there's even stuff that's never been developed that needs to be worked on, such as lighting systems, general maintenance tools. What if something breaks? How do you fix it? Pliers, crescent wrenches, sockets, ratchets, cutters. You can't just go to your local Home Depot and pick the stuff up off the shelf. Although that is done from time to time, you're going to experience temperatures in the dark of 200 to 250 degrees below zero. Pretty sure none of our socket wrench sets that we have in our garages were built to withstand temperatures that low. So we need to develop new stuff to be able to handle the daytime temperatures of 200 degrees above zero, or nighttime temperatures down to 200 below. and the spacesuits as well. You can see the white spacesuits here. This is actually a prototype of the spacesuit. This particular one is black. It will not be black. This was to mask some proprietary technology. So it does not quite look like the real thing when they introduced this to the world about a year ago. But Axiom Space is producing the lunar spacesuit. So this is what the spacesuit will look like. Will the astronauts be able to handle all those tools, all those sharp, pointy tools, and still wear their spacesuits safely? So there's a lot that needs to be done. Artemis is risky. Artemis is expensive. Artemis could be potentially extremely rewarding. Maybe the next step in long-term habitation of the moon, maybe the next step in human exploration of Mars. A lot of things have to go right for all this to work, and a lot of it still has not been fully developed or tested yet. So I hope that was at least a helpful overview, not too complicated, of how all this will work. I would love to know if you have questions. I'm going to stop sharing. Um, if you have any questions, please go ahead and throw those in the chat or the Q&A. It actually doesn't matter to me which one it goes into, so feel free to type those in if you have any questions. Christina, I know you always have some great questions. Do you have any for me?
Yeah, so I noticed in your diagrams of the different Artemis missions, it seems to be launching from like the Caribbean, or is it just, or is it Florida? Where is it launching from?
Florida, yeah,
Florida.
Kennedy Space
Okay.
Center.
Okay. Does it have to launch from Florida in order to end up where it wants to end up?
That's a really great question.
Okay.
It The answer is if the United States had territory, had any part of a state that was located closer to the equator, that would actually be a better place to launch from. So technically, Hawaii would be great to launch from. The problem is it's literally in the middle of the Pacific Ocean. It is farther south. It is closer to the equator. The closer to the equator you are, the more oomph you get for a rocket being pushed by the rotation of the Earth itself. So it's fat. We rotate. The biggest oomph we get is from the area at the equator. The farther north you go or the farther south you go for where your launch pad is located, the less oomph you get, the less fast, the less speed you get added to your rocket launch. But Kennedy Space Center is the farthest south that the United States has to be able to launch from. The European Space Agency has a launching area for their uncrewed spacecraft, their big ones, in French Guiana, so an island off of South America. But that's actually a lot closer to the equator, so it gets a little more boost from the rotation of the Earth. But the reason we don't have one uh, in a different location is that's about as far south as we can go and still be in the mainland United States to be able to have our launch pad. But you could be farther south if you had a launch pad to use. Um, but since these are all involving people, that's where we launch the people from.
Okay. So I guess this kind of falls into my next question, which is this just an American mission, or does it involve international scientists?
Yes. So one of the first one of the Artemis 2 astronauts is Canadian. So he qualified as a NASA astronaut, but he's a Canadian astronaut. Eventually, there should be European, Japanese, Canadian astronauts on these missions as well. They haven't selected the crews out past Artemis 2 yet, or if they haven't announced them yet. So I would expect there to be more international participation because we've got these other countries participating in the Lunar Gateway space station part of it. So basically, you put in this much money, you get this much access out of out of the whole thing. So yes, there will be significant international participation because all of this will be way more expensive than one country can handle. So the U.S. is definitely looking for more participation from other countries. Yes.
So now I have another question. And if anybody else out there has any questions, please feel free to put them in. You were showing all those images of other man-made objects on the moon that we have sent there or other countries have sent there. It seems like, as you said, it's a very large space. It's a big place. We've only landed in so many places. Is there any discussion about the accumulation of all that stuff that's like, going to break down and deteriorate on the surface? What happens to all that junk?
That is an amazing question. So there are currently a bunch of countries that have signed on to what are being called the Artemis Accords. And it's something like 30 countries or something like that that have signed on. And it's a lot of countries that don't currently have space programs of their own, but it's a bunch that do as well. So the goal of the Artemis Accords is a bunch of countries all agreeing to peaceful use of space. Not only that, there needs to be discussion about the prior Space Act treaties that were Space Act treaty that was signed decades ago at this point. But that essentially said nobody owns space. Nobody owns stuff in space. Well, at the time that all that was originally talked about, discussed, and signed, and we're talking 50 years ago, 40 years ago, nobody was going to bring any of that stuff back. We just didn't have the ability, the money, the will to be able to do it. Now we're getting private companies that can land successfully on the surface of the moon. We've got China that can land successfully on the surface of the moon. Russia, European, or not European Space Agency, not yet. India, all that. All these countries are sending stuff. What if some private company decided they were going to land at the Apollo 11 landing site and they're going to trundle a little uncrewed rover over to the American flag that's sitting on the ground because the Apollo, the top part that came off and brought Buzz Aldrin and Neil Armstrong up off the surface of the moon, the rocket exhaust blew over the flag when it took off. Well, what if they decide they're going to go grab that flag and bring it back? What do you do? Are they in trouble? Is it finders keepers? Is it a museum? Do we just leave everything where it is? All this needs to be discussed and hammered out because now we have the ability for it's not easy to get that stuff back. Half of all missions have landed unsuccessfully on the surface of the moon, but it's now becoming a reality that we actually have to do something about this. So right now, there isn't a clear-cut answer to your question because I think they need to kind of figure that out. But at least there's a bunch, dozens of countries that have said, we agree to peaceful use of space. So that's something. But now we need to talk about economic use of space and who owns what. And if you dig it out of the ground, does it belong to you or what? So anyway, to be determined on all that. It's a great question. How are the systems engineering and strategic planning teams structured? Oh boy. So generally the way that NASA works is NASA itself does not have a giant workforce. NASA consists of NASA and lots of contractors. So you've got one company that might do the electrical systems for Orion, and another company might provide the seats. Another company provides the spacesuits. Another company provides X and such and whatever. So there are a lot of contractor companies that provide certain pieces and parts, and that also adds to the complexity. But this is the way that NASA has done this for decades. This is the way that it works. So you've got NASA overseeing all of that, And then also you've got these private companies that are involved as well. It isn't just the contractors providing something for the Orion spacecraft. You've got SpaceX and you've got Boeing and you've got uh, um, Blue Origin and these other companies providing whole pieces of this whole system, like the whole lunar lander that'll carry people to the surface of the moon. The whole thing might be provided by SpaceX or Blue Origin. So we've got private, uh, public-private contracts where NASA says this part of our budget, we're going to hand it to SpaceX, and for that part, for that cost, you will have to develop the stuff that we need for whatever it is that you said you were going to provide. It's handing whole pieces to other companies, and that's different from how a lot of the earlier space program stuff was done, where if something went wrong, it's not like Lockheed Martin was providing the entire space shuttle. Um, so it's complicated to say the least. But NASA is overseeing all of that, so nothing gets off a NASA launch pad without it passing a lot of tests and a lot of mission assurance. So it's not like SpaceX will go, oh, we just want to throw some astronauts on a rocket and hey, let them go into space. Oops, something went wrong. I mean, something could go wrong, but they have to prove to NASA that their stuff is safe. That's why all this testing happens before you send people up. So that's the easiest way I can describe um, all of that. Then the last major piece is you've got these outside organizations and advisory teams that basically take a look at all this and go, ooh, that's really complicated. Hey, NASA, you may want to do something a little different with this plan right here because this stuff over here, I don't think that's going to work. Maybe do this other stuff over here. So there's different advisory teams that advise NASA on a yearly or semi-yearly basis on various plans for spacecraft missions involving people and spacecraft missions that don't involve people and things like that. So that was the easy way to describe how it all works. So,
All
all right.
right. Well, if there's any other questions, please feel free to type those in. I'm kind of winding down with my own questions. I'm really curious to know, once they do finally have everything in place and they're ready to launch, can ordinary people go to like view it?
Absolutely. Yes, you can. And you can always do that. So on NASA's website, nasa.gov, there is somewhere near the top of the page, there's I think it's a missions tab or something like that. You click that and it'll show you a little drop down. And one of them should be in the drop down should be launches and landings. And if you click that, you can see which ones are going to launch from which location. So mostly they're going to launch from mostly the rockets that NASA sends up launch from Kennedy Space Center. But sometimes there are smaller rockets carrying scientific payloads or something. They might launch from the Wallops facility out on the East Coast. It's in Virginia, I think. I think that's where it is. And also sometimes stuff launches from Vandenberg Air Force Base out on the West Coast. That's mostly if it's going on a north-south orbit. But you can see when these are, and if NASA is hosting a viewing party for one of those, check and see if they've got tickets available. And even if you can't get a ticket to get on site at Kennedy Space Center and watch a launch directly, go get yourself a condo at Cocoa Beach or in Melbourne, Florida, or wherever in that general vicinity, Titusville or a little bit north of there, and you can sit on the beach and watch these things go up into space, which is really cool.
That
And
is so cool.
yeah, so when there was a space camp facility just outside the gates of Kennedy Space Center, I worked there for a couple summers in the early 90s, and we got to see launches and space shuttle landings all the time because They were right there, 10 miles away. And so we could just go up on the roof of Space Camp and watch this stuff. That facility is no longer there, but you can still do all of that. And if you ever get the chance to get what's called a NASA Causeway Pass, that gets you within maybe about 5-ish miles, maybe a little farther from the launch pad. That's really cool. I did that once for space shuttle launch. So yeah, it's really
I
cool.
I'm adding that to my bucket list now that I know. Even I see I'm probably more likely to be like further away. So I can view it safely. But yeah, that's definitely something I want to see for sure. So that's really great advice. I'm gonna be looking at nasa.gov and
There you go.
be
And
planning a future vacation.
and VRBO and Airbnb and all that
Yes.
stuff. Yep. I mean, heck, if you even have an east facing window at a tall high-rise hotel in Orlando,
Mm-hmm.
especially at night, you can easily see night launches from Orlando, and you can even see daytime launches from Orlando. They're just not as exciting because you see this little dot of light going up into the sky, but you can
Oh,
still see it.
so true.
So yeah.
Okay, well, in the meantime, I'm gonna settle for Instagram because the Artemis, they have a great Instagram account with really cute pictures of all like the astronauts in their big suits out in the desert doing things. It's cute.
It's really cool. It's neat to see the progress. It's so slow. But,
Yeah.
I'd rather have them go slow and get it right
Yes.
than speed it up just for the sake of speeding it up. We've seen a few different times in NASA's history where that has not turned out well. So,
Oh.
yeah,
Yeah, and we really want to encourage younger people to get into those fields and, they should feel safe.
exactly. Exactly. And there's plenty of stuff to do for people on the ground. If you go, not for me, I'm not going in space, but there's
Mhm.
so many people. There's 4 people who go into space, and there's tens of thousands of people involved on the ground to get them safely into space and get them safely back from space. So there's a lot more for people to do in that realm than actually going to space.
True, so true. Okay, well, we're gonna have to reconvene when we get closer to the actual launch and go over this again if it's gonna be years in the future.
Well, fingers crossed, and we keep planning. Every once in a while, I'll get a request from a library to do this particular program because they will have said, "Oh, the next launch is supposed to be summer 2024." Like, nope, November 2024. Like, oh, okay, well, oh, now it's September 2025, and
Yeah,
well, it's hard to actually lock in a date, but hopefully, we'll see Artemis 2 in the next year and a half.
yeah. Well, in the meantime, you're gonna be back with us in September on the 30th for comets and asteroids, and there may be, like you said, a big comet coming up.
There may be a bright comet visible at that exact period of time, which is why we picked that one. So stay tuned. Join us on that one. So it's 6:30 p.m. on September 30th, if I'm not mistaken.
Yes.
And so yeah, join us because I will, if that one is actually worth looking at, I will have information about how you can see it easily, hopefully.
That's great. I'm so excited. I don't think I've ever seen a comet, so I'm hoping. I'm got my fingers crossed.
Excellent.
All right. Well, thank you again, Michelle. It was lovely having you back with us, and we'll see you in September.
Thank you so much. Have a great summer, everyone. Take care.
All right. Bye. Good night.
Bye.